So the session title, Zero to Hero in Kubernetes Native Java. So I believe a lot of people joined the call. Thanks again for joining my session. And you probably like a Java developer, or even not, I believe you got some experience with Java development like in the past. So today I'm going to give you a chance to how to become the superhero in a cloud native Java application. So let's get started. So let me try to really talk about myself. My name is Daniel Oh. I'm working for Red Hat as a developer advocate, specialized in cloud native runtimes, which is Quarkus and Spring Boot and JavaScript like a Node.js. I'm spending a lot of time to bring these cloud native runtimes into Kubernetes with the serverless and service mesh and GitOps practice across OpenShift cluster, which is a Red Hat like a Kubernetes enterprise version. I'm also responsible for the CNCF ambassador, which means I try to evangelize like a cloud native architecture and application development, deployment, and also multi-cloud, hybrid cloud strategy for developer as well as SRE cross admin across the industry for the last couple of years. And here's my quick contact information. You can follow my Twitter, Daniel030, and my YouTube channel, bit.ly URL Daniel TV, and you can copy my old existing project and then tutorials and then demo example, my GitHub repository, Daniel030. All right, let's get started. So just in case who never ever heard about Quarkus before, so the Quarkus is a new Java framework the Red Hat invented a couple of years ago, actually 3.5 years ago, and a lot of individual developers and then vendors jump into this project and then make it better every single day. So Quarkus community project, 100% open source. We release this Quarkus project every 2 weeks, periodically, and then AKA Supersonic Subatomic Java. Every single Java framework was born for Kubernetes and then Linux container technology. With that, the traditional, even cloud native Java framework try to optimize, fit in the cloud native and then Kubernetes native and then Linux container technology. However, there are always some kind of limitation to optimize to memory footprint and startup time and response time and the scalability and resilience, a lot of stuff on the Kubernetes. So Quarkus actually solved that kind of problem because Quarkus designed based on Kubernetes, like a serverless and a high scalability and performance and the event-driven application on top of the Kubernetes. So here are a few bullet points why Quarkus is called supersonic and subatomic, because Quarkus try to move as much as possible to build phase. Everybody know when you run Java application, behind the scene, there are a lot of stuff happening underneath. For example, parsing annotation and describe scanning and then enable, disable some specific features, and also try to load the actual business logic using process or thread. It's kind of happening all the time, which is just so dynamic behavior, which is just so good at the backend, like a 1995 or 2000. At a time, the Java application has immediate code, and then you can run any virtual machine, like a Java virtual machine, like any vendor's Java app server, which is really cool at a time. However, things have changed that the infrastructure, like a runtime environment, moving forward to immutable infrastructure, aka Kubernetes, with Linux containers. So sometimes your single microservice application should be scaled out like 100 pods or even 100,000 container pods. So with that dynamic behavior, so not good productive way, effective way with that infrastructure. So Quarkus minimize runtime dependency and minimize the dead code elimination. And then more important thing is Quarkus improve a lot of developer productivity features. I'm going to showcase that kind of stuff in a minute as a live demo. So this is just some good diagram how Quarkus is doing for developer. This is a build time. And then the upper side is, so this is the traditional like a Java framework, for example, a Spring Boot. And then you're gonna build your application, Java application using your pre-produced packaging tool, a build tool like a Maven or Gradle, even Kotlin. And then when you run Java application, there are a bunch of stuff happen underneath. For example, I already mentioned earlier the scan annotation and the parse descriptor, and enable, disable some kind of feature based on annotation. And also there are so much stuff happening before running actual process or thread. And then as you can see, the bottom line, the Quarkus actually shift that kind of stuff as much as possible from right hand to left hand. So when you run Quarkus, it just run start thread or process. That's Quarkus really faster. And also Quarkus allows the developer to packaging application two different ways. One is creating like a fast jar, like a thin jar running on JVM. The other one is you can create a native executable file, just run a GraalVM without the JVM. Just imagine that like an exe file on the Windows operating system. And then so with the Kubernetes, like a container platform, so just imagine that you can have the same resource density worker on your Kubernetes. You have the like a, let's say 4 worker node on your container platform. And then the left-hand side, you could just only run for Microsoft's application as a pod. And then if you take the Node.js application to implement same business logic, you can have maybe a double pod, number of double pods, for example, 8 pods. And then the Golang maybe a 24, which is third time compared to traditional clean Java stack like a Spring Boot. This is the evidence people really want to use Node.js like JavaScript technology or Golang rather than Java. And then people say, oh, Java is a pretty heavyweight and pretty slow to run that kind of application on Kubernetes, specifically serverless or even general just traditional application. However, as you can see, the third tile in the worker node, the Quarkus with the native executable is almost similar resource density to Golang. So which is a really important thing. So out there, there are more than 50 million Java developers still working to develop application, maintaining application, and tune performance issue every single day on the business application and the enterprise companies. And then we cannot ignore those Java developers. And then we let the Java developer maintain their skill set and their career path with the Java, with that Quarkus. And then here's a quick illustration how to become superhero with the Java application, specifically Kubernetes native one. So you can start Java application with the Quarkus framework from scratch, and then you can add it on some specific capability, for example, live coding and the continuous testing, and also native compilation. And then also there are a bunch of the developer enhancement capability for your inner loop and outer loop development. And in the end, when you deploy this application, you might need to think about how to make my Microsoft's application as cloud native way, which means, for example, you have some kind of configuration needed to store some kind of Kubernetes resources, such as a secret or complement rather than local file system or some kind of database. This is a Kubernetes way, because whenever you your application pod restart or scale out, Kubernetes automatically attaches that configuration or secret information automatically rather than reporting to some specific file system. That is a Kubernetes way. And then how to enable the Kubernetes manifesto or Kubernetes feature into my Microsoft Java application. Maybe you needed to create like a YAML file for the Kubernetes manifesto, or you're going to add a specific third-party library on top of your Java application project. So pretty annoying for Java developer to learn something new with a steep learning curve. So Quarkus just eliminate that kind of stuff. like a roadblock, and then just could easily enable your Kubernetes integration into your Microsoft Java application. So ready to become superhero today. So I'm going to start my slide deck, and let's get right into the demo, how it works. So I'm going to start my sharing, and then so maybe there are several ways to start Quarkus project. Well, one of the easiest way, you can go to Quarkus.io. This is the official page. Let me try that. And Quarkus.io. You can find like a bunch of the guide, and then community support and the blog post, and how to discuss your some technical issue or suggestion. And you click on start coding, which will bring you into a project generator very similar to Spring Initializer. If you have any experience Spring developer stuff, and then you can change group ID and artifact ID. You can select build to like a Maven, Gradle, or Kotlin, and then you can select Java version 11, 17, and you can set it up like an example code. And then there are more than 500 extensions today. For example, this is all kind of your business applications capability. For example, I need to create like a RESTful API with a web application. You can select a REST reactive or JSON-B or JSON parsing JSON format. And also there are data transaction and our cloud, and then a messaging broker, and there's so many stuff here. You can just click on that dependency and then generate your application. It automatically downloads zip file and unzip, and then just start with application development. However, so today I'm going to try to using another interesting way, which is Quarkus CLI. So Quarkus CLI, you can just install Quarkus CLI with a multiple way, like a SDK on the macOS or JBang based on JavaScript, or you can download binary. So whatever you take to the path, and it's pretty easy to install Quarkus CLI. Maybe some developers say, oh, I don't want to install Quarkus CLI. I'm just using like my existing tool, like a Maven, Gradle, go for it. And then, but Quarkus CLI, one of the benefits for developer, you can easily create and build and then a bunch of stuff for your innovative development process. And in the auto completion feature, which allows you reduce your memory or stuff. So you don't need to remember all Maven or Gradle command lines. So I'm going to create a new project, Kubernetes Native Java, and it automatically create a bunch of a file and generate that resources here. So today morning, we actually released a new Quarkus version 2.12.2. So I just create a new one, and then as you can see, I just generate the Maven wrapper and the computation properties in a Docker file in case I want to deploy this application to Kubernetes. And then here is a sample application, REST Easy. The Quarkus was designed based on reactive the characteristic and engine. So whenever you develop reactive application, it's pretty hard because, for example, Spring React is totally different animal compared to imperative Spring framework. You need to rewrite a bunch of the application for reactive programming. However, Quarkus actually designed and built on reactive engine, which is a Vertex and Netty. So you can keep developing reactive application, but also imperative application at the same time, as long as you're going to use the prepared annotation and maybe dependency or Gradle module. So I'm going to open the new project for Kubernetes Native using my ID tool, like a VS Code. Then I'm going to make it bigger a little bit, zoom in, everybody see it doing it. And then here's my application, like a POM XML. So the current version 2.12.3, the latest one I just mentioned that we released this today. And then here's a few dependencies already downloaded on my local file system. For example, the Quarkus R and REST reactive. This is just reactive application. And then I'm going to use Java 11 at this moment. If you want Java 17, you're going to just if you set the Java home like a Java 17, it automatically generates the Java 17 based application. And then here's your main directory. In the sample application, just hello, RESTful API, and return just simple text code. And then every single time when you start Quarkus application, you need to use a Quarkus dev mode, which is Quarkus dev, or you can use a Maven Quarkus dev. So this is allows developer to have live coding capability, which is really cool. So whenever you change the code, it automatically auto-wire the change the code into your runtime. As you can see, now you can see your profile dev activated and live coding activated. What does exactly that mean? So when you press W from runtime, it automatically go to landing page, and then click on the endpoint, and then you can see hello from Mess Easy, and then back to the dev UI, and here's the dev UI. So this is one of the great way to showcase graphical GUI for developer a bunch of the features. So for example, you already edited a bunch of the maybe dependencies, and we could say Quarkus extensions, and then maybe sometimes you cannot remember which extension and maybe dependency are already embedded by Java project. So this is showcase graphical way, and also you can open it the read-only terminal window, just like here. And then once you click on test is not running, and you can click on the testing, it automatically start continuous testing. So a lot of enterprise company really focus on test-driven development. In order to achieve, a single individual developer need to add like a test unique case on your Java project whenever they change the code, bug fix, or even propose tuning. But this is really hard because a lot of developers complain about it. We don't have enough time to add test unit case. I just more focus on application development itself because I'm pretty sure my application doesn't have any issues. However, sometimes you got some issue or error, which is only because the application logic only working on your local, not production. However, when you just committed that code in your Git repository, it automatically deploys to your production environment in the next 3 minutes with your fantastic CI/CD tool like a Jenkins or GitHub Action, something like that. So in order to avoid that kind of human error, you need to follow test-driven development practices. But Quarkus actually provide out-of-box feature to test-driven development on your Java framework. So once you turn it on, and it automatically showcase that kind of stuff. So let's go back to here. You can see test cases passing, and you can actually see the test result. Here is the test result, the passing with the green color. When you go back to project in the test directory, we have one single test case automatically generated based on our sample application, hello REST endpoint, and then the test result. So when you go back to like a terminal window, switch it to a new window and try to endpoint once again, just double check. I gotta run the hello from Mess Easy reactive, and then back to the application. I'm gonna change that from like a JCON, and then save a file and back to here, and then just invoke a new URL. I got a new one, hello from JCON. This is a really live coding. So I don't even try to recompile, rebuild, and redeploy and restart my runtime. This is a normal practice for inner development. But I just change the code and it's just happening, just like a JavaScript. Not gonna happen for the last 2 decades in the Java world. But now you have this kind of stuff like a live coding capability, which really, in the end, it improve and your developer productivity and reduce your whole developer life cycle. However, when you go back to runtime environment, I got some error. So test case failed because the actual return from JCON, but expected less easy. You can also go back to dev UI, and then you can see the same result here, the error, and also you can find here, find the error here. So I don't even try to like a Maven verify and then or some test case running. It automatically show that based on continuous testing the out-of-box feature on Quarkus framework. So just Java developer standpoint, you just keep doing whatever you need, like writing code and just check the verify application. So verify to fix that problem. Go back to here, and then save a file, and then back to here. Hello, oh yeah, and then well, save a file, and now it's a test case succeed, and then back to here, you got the green color again. Whenever you change the code, it's already happening. So let's try to add a new method on my application before I deploy this application and edit some Kubernetes stuff. So I'm going to try to add one more time the new pass test case based on the test-driven development practice. Let's try to add a new one is greeting and a new endpoint like a greeting, and then hello from JCON, and then my name Dan, report name, and then back to the terminal. And then you got some error for error because I added my test case, but I don't have any resources to map my test cases. That's why for error. So now let's copy EDC1 and create a new one, and then new pass here, like a greeting, and then pass greeting, and then here is the sometimes like a name. So I'm not gonna put in the static code, so it's a more common practice. I'm gonna read that name from my configuration, like my local file system. You know, I'm gonna do annotation to configure properly here, and then name, which is a name, and then the string value, which is a name. Let's save a file, and back to the runtime, and I got a new error here. Oh, you cannot load your configuration value with the name. So really cool. And then I'm going to open resource file. And let's say try to name, because then I save a file and back to runtime. And I got a two cases is working. Back to WI, and you can see, so two test cases are just passed, which is cool. And let's try to endpoint like a greeting. And now you got the hello from JCON, Dan, which is cool. And one interesting part in WI, here is the configure editor. And you can see the Dan, maybe I'm going to change that Daniel, and then just click on apply and update successful. And back to here, and then I say invoke once again. I got some hello JCON Daniel. What happened in there? Because when you go back to my file system, it's already changed automatically from WI in my local system. However, I'm gonna fail once again because the test case is just still looking at that. So now I'm gonna fix my problem here, Daniel, and now I got the test case 2 pass, and then my application is still working, which is cool. So this is I'm gonna showcase how to make it faster development for Java developer, specifically like Kubernetes environment. But this is not actually, I'm not going to deploy Kubernetes, but I just say I don't have enough because your developer in order to out of the process, it will be expanded from your local to Kubernetes, and which means you need to spend more time with the Kubernetes stuff. So with the Quarkus, it reduces your in order process developing, testing, or verifying, and also like keep adding your application loading like a live coding stuff. So I'm going to start my demo, and then I'm going to try to build my application. So when I build application, it automatically try to verify the unit tests as well. And in the end, it will generate like a Ninja. The Quarkus side, we can say faster because we override the Java class loader, make it faster. So we're not going to say uberjar and a fetcher. So now I'm going to go to run Java application, something like a jar, and then target directory and run application. But for that, here's my activity window. So let me try to open it. Okay, cool. And then try to find out Java. So I have a bunch of Java here. JVM, so one step, and then so I'm going to run this application Java runtime. As you can see, this is running JVM, and then start it here 1 second to start up, and then back to the here the active monitor. So the main memory footprint for the just JVM 92, so pretty good. And then once you run and invoke the RESTful API, it really increase the memory footprint like 95, something like that. We try it one more time, maybe slide up or not, like 95, let's say. So this is the progress is super fast, still one rest like almost like 1 second. If you start one more time, maybe a little bit faster, like still 1 second, or sometimes it depends on how many dependency you have. Okay, so now I'm going to try to one more time corpus build. I'm going to unit speed the unit test. It will make it faster, and then try to make a native. So this is I already mentioned earlier. So it's gonna package your application as a native executable, not gonna run on JVM, but running on GraalVM, which is like a technically substrate VM. As you can see, we're gonna use the GraalVM, the version base 1 in Java 11. You can also using GraalVM on Java 17. It takes a little bit longer than just a build like the thin jar, because once you package it and build the thin jar, and then we're gonna like this is the thin jar, and then we're gonna package it once executable file, just like imagine and put it like a relevant dependency and then all kind of stuff. So once you make a native executable file, and then you can run without Java command line. So here's the thing. So I'm not going to say you and developer needed to build native executable all the time whenever you change the code. However, maybe you could delegate this kind of task into your CI/CD pipeline, not on your local machine, because sometimes you got some issue to run Java application on Kubernetes or Amazon Lambda. It takes some time. It starts like a 2 second, 3 second, even 5 seconds. However, with native executable, maybe it takes like a millisecond startup time, which is super fast. It's a really benefit for your resource optimization on top of the Kubernetes or even public cloud with the serverless platform like Amazon Lambda, Google function, and Azure function, etc. So that's why it takes some time to build executable file. And then, so once we're done, we're gonna run this kind of stuff. And then what we're gonna do next step, I'm gonna add like a Kubernetes native stuff. For example, I'm gonna try to repair some of the secret information. For example, I needed to store my, okay, I just done, and then let's try to see the target inventory, and here's the executable file. So let's try to run the file directly, and then now you can see running on native, and also we're gonna start up time like a 30 milliseconds. So previously we just needed 1 second, now we're gonna 30 milliseconds. It's almost like a 33 times faster startup time. And then when you go back to activity monitor, and then previously we almost 95 memory footprint, the same application, and now we have 12 memory footprint in almost like a 10 times or 9 times less memory footprint. And when you try to access the REST API, it will be increased about 12 one still, try to several times, and then it's 13 right now. So pretty small memory footprint. That's why we call supersonic, subatomic, and quartus. Okay. So let's go back to here and then stop here. And I'm gonna add a few more Kubernetes stuff. So for example, I need to store my sensitive information. For example, the data, the database username and password. I'm not gonna store that kind of thing, the database with the encoding and decoding stuff. However, in order to make my application more Kubernetes memory, I'm gonna store that kind of stuff into Kubernetes secret, which is one of the cool way to store your sensitive information, and then whenever you your application path get out or restore or redeployed, Kubernetes automatically attach your secret information. It's a really Kubernetes way. In order to that, Quarkus actually provide the Kubernetes config extension like a Kubernetes config, which allows me to access directly Kubernetes resources like complement or secret information. And I also needed to add the OpenShift extension, which allows the developer to build application and generate the Kubernetes and OpenShift the Red Hat Kubernetes stuff, the manifester, and deploy to the Kubernetes cluster. Okay, so let's try go back to my application and then back to here and then try to add a new application, for example. Okay, but for that, I already my own Kubernetes cluster here. It's the Red Hat Developer Sandbox is a free Kubernetes cluster for just individual developer. When you sign up the developer at redhat.com, so here developer at developers.redhat.com, and then go to starting sandbox. When you signed up this program for free, and you're gonna have a 30 days free access OpenShift Kubernetes cluster. So I'm going to use this one today. Here's my namespace DOH8dev, and there's no resource file. This is just empty namespace. Let me try to make sure I already log in my namespace. Here we go, DOH dev. Okay, pretty cool. And I'm going to create a new secret like a DB credential here, and the username, admin, and password is secret. Okay, maybe I'm gonna try to. Oh yeah, I'm gonna log in. So in order to that, Sandbox is provided pretty cool stuff. Login mechanism here. So I'm gonna copy this token and then try to create a new one, DB credential, which is cool. And when I go back to dev console, you can find the new credential just now, right here. And you can also actually build in here, secret and admin, which is cool. Back to topology. And now go to application. And then I'm gonna try to enable Kubernetes config and secret, which is DB credential. And then it's enable and true. So this is a two configuration allows me to access directly complement and just not secret on the Kubernetes cluster. And then back to the application. Now I'm going to try to create a new config here to access that kind of stuff. Name, like a username. Name, there we go. And copy here. And then another key is a password. This is cool. And now I'm gonna do new endpoint like a secret. I'm gonna try to secret, and the return is map string because the key and value. And then let's try to create a new hash map. String, like the map. Let's try to new hash map. There we go, and then map. And put that key. Let's say to the key is DB username, and then value, which is the config from the secret. So, and then the other key is password. Password. man. Okay, so this is not going to working on my local right now because it should be running on Kubernetes. Okay, I just create a new endpoint here. And I'm going to add a few more configuration. For example, deploy this application, Kubernetes, deploy true, and also deploy target, which is Kubernetes or OpenShift or Knative for serverless application. And I'm going to create the route URL automatically FTDN based on HTTP proxy. And then the support. So the developer sandbox basically use the self-certificate for TLS termination. So that's why I make this configuration true. I'm going to use the self-certificate termination for TLS termination. Okay, and then I'm going to add one more interesting part. So whenever one of the beauty of a Linux container is the immutability and portability on top of the Kubernetes. And then once you deploy Linux container as a pod on top of the Kubernetes, it's not going to change that. Technically, you could change that when you exit that inside pod and change the file. However, when you kill the pod and automatically store, and then the change stuff is gone. That's why we can say immutability. However, for developer perspective, sometimes you got some error or issue from your SR team or cross-admin team. Hey, Dan, we got some error in your application on top of our production. And can you take a look at that? Sure, I can do that. However, I'm going to try to find out error, but the pod is already deleted and the kill and the restart, which means the log is already gone. Sometimes your production environment already have like a log aggregation infrastructure, like a Dynatrace or some kind of big giant Splunk, and it's really find that relevant logs at the same time because there are so many logs in keep collecting. So if you could just have live coding capability on your local machine to remote Kubernetes, which is really cool for your inner and outer loop development process. So Quarkus will make that happen with some few configuration here. So I'm going to add that like a package type, so mutable. As I say, I'm going to try this configuration make your Linux container pod as mutable, not immutable, and also library load. Library load password. This is only secret password. Any password between your local and the remote Kubernetes cluster, and also library load. And URL. So we're gonna update the URL once we deploy. And then one last thing is Quarkus and OpenShift. OpenShift environment variable, which is Quarkus. Oh, sure. Okay, it's done. And then back to the terminal. And then now I'm going to try to Quarkus build. I'm going to just skip unit tests to save my time. So there are multiple steps going to be happening here. So first of all, we're going to packaging the flash jar. And then we're going to try to access the Kubernetes with the API and then packaging the container image. As you can see, back to the application. When I generate the project, the Docker file automatically generate for JVM or even legacy jar, which is a fetcher. Sometimes you might need to use a fetcher along with your Kubernetes environment. And here the native and then some native micro is pretty compact. You are using the micro-based imaging. So this is the one of the cool thing for developer. You don't need to create a Docker file to build Docker image, and then Quarkus automatically generate this kind of Docker file as well. It automatically took Quarkus build text this Docker file to build application. So once you deploy the application and it create to, and also back to the here. And when you go to target directory, and then under the Kubernetes, and you can see some kind of YAML file automatically generate. When you set it up, the target environment to Kubernetes, the generated file name should be Kubernetes YAML or Kubernetes JSON file. So this is all required resources when you deploy your Java application to OpenShift as well as Kubernetes, like a service account and service, and then the route URL, which allows you access your application from external user using AppQD and URL, and then deployment and load environment, that kind of stuff, which means you don't need to create or write it down your YAML file for Kubernetes resources or OpenShift resources at all. And then back to the application. Okay, we just done. I could go back to dev UI. Now you have a new application here. Now let's try to view roles. As you can see, the dev activated and live coding activity, which is cool. Just like your local environment. And then I'm just copy, this is a route URL and back to the terminal and try to access hello. And then here is from JCON, greeting, and then from JCON, Daniel. And then let's try to new API secret. And now you got some, sorry about that. So DB password secret username admin, just like our secret here, create the DB credential. And the same thing. So we just extract that kind of resources from application, which is cool. So now I'm go back to here. One more thing. They'll go back to resources and then uncomment and copy to our pod the URL, and then back to here. And I'm going to try to using Maven command at this moment. Maven command and Quarkus remote to that. So this command line try to connect to from my local runtime to remote Kubernetes cluster based on password, and then here is the URL. And now we connect to server. So let's try to go back to working project and try to resources. Let's try to change the JCON with native Java. Save a file, and then back to here, and I'm going to call the RESTful UI, and then back to the runtime. You can see automatically detect the change in the file and the packaging job and sending it to that. And now we got a new return code, but this is not local. I just changed my code from my local, but this is happening by remote Kubernetes cluster in the actually the dev sandbox and running on Amazon. And then let's try to change another stuff, even configuration file, Daniel, and I'm gonna like a Daniel. Oh, save a file, and then try to agree. And then you can see the change that Daniel O, and then you can see automatically picked it up application property file, automatically detected and sending to the remote cluster. So whatever you change there, it automatically repackaging and deploy to sending to remote Kubernetes cluster. This is really cool stuff. So, and then back to the resource file, and then whatever you change there is keep changing that, and then like a and purpose. One more time. Using Quarkus and save a file, and back to the terminal, and I'm going to the hello, and then you're going to automatically packaging and sending to Java file, and now you're going to go hello from JCON with the Kubernetes native Java using Quarkus. So this is a pretty awesome stuff. And then I'm going to go back to my slide where So quick summarize today stuff. Back to scenario, and then in the meantime, let me take a look at. There are some questions there. So I don't see any questions. So if you have any question, and feel free put on the chat or reach out to me directly. All right. So I'm pretty sure you're gonna find the shortest way and easiest way to become a superhero with developing a Kubernetes native Java application right now. And it just I'm pretty encouraging you all to subscribe my YouTube channel, pin the URL or your QR code here if you're using mobile phone. And then I already uploaded more than hundreds of the tutorial and the technical demo around Quarkus application and serverless function and the GitOps pipeline and DevOps Insight and the Kubernetes Runby example. So I already published the similar demo video as well. So if you have any question, well, you could give me some suggestion. Hey, Dan, why don't you create some cool video like how to develop my Java application with the Argo CD GitOps pipeline? I'm more than happy to create a new video with your suggestion. So feel free and then subscribe my channel and then add your comment and then any technical question. So thanks again to joining my session today. And once again, so Quarkus is a free 100% open source project. And then with the dev, you can build cloud native, not cloud native, more like a Kubernetes native Java application with the native compilation. And you can also improve your developer productivity, like a live coding, continuous testing, as well as you can easily enable Kubernetes feature like a config map or deployment and build with a Docker container and Podman, as well as enable like Kubernetes feature, for example, config map and secret. And there are a bunch of stuff you can easily improve your existing microservices into Kubernetes native application with a more high scalability and then performance improvement. All right, I think so. We're almost done, and thanks again joining session. And I hope you enjoy my session, my demo as well. And the last thing, and I hope you enjoy the rest of the JCON, and we'll see you next time. Thank you.